This sounds better. Can you guys hear me? Yes. All right. Who here likes spring? Yeah. Cool. All right. Thanks for coming to our first spring conference. Let's give yourselves and our speakers, everyone, a round of applause. So bit of housekeeping, and then we're going to get started. So first off, I did promise everyone a shirt. We ran out of shirts. So come find me. Give me your email. If you didn't get a shirt, I owe you a shirt. May not be the same shirt that everyone else got, but it will be a spring or pivotal shirt. So come find me. So all of us volunteers have white spring shirts with staff written on the back. If you have any questions throughout the day, just come find some of us. We've got a website. You can all pull it up on your phones. It's Toronto Spring Conference. So it's toronto-spring-conference.cfapps.io. The schedule's on there. Announcements will be on there. And if we make any schedule changes, for instance, one of our speakers hasn't arrived yet, so we might have to shuffle things around. Like he's still on a plane, so most likely we will. So there will be some changes. So speaking of sessions, this will be the main session room. There's going to be 2 rooms downstairs where there are sessions. We have signs that are going to point you to all those places. If you get lost, one of the volunteers can help you. When you're going downstairs, this is our office, so there are people working. So maybe when you're walking in between sessions, just try and keep the chatter to a minimum. Now, we do have a charging station just over here to the left beside the kitchen. Feel free to hang out there and charge. If you need to make phone calls or socialize, downstairs in our other kitchen is where you can hang out, chat, take phone calls, what have you. What else? How about our speakers? All speakers, can you raise your hand? I mean, everyone knows this guy. Maybe actually stand up. Now I'm making you guys work. So maybe what I'll do we have the catch box? How about I just toss the catch box to each speaker? You can say who you are and what your session is. We also have some sponsors here I'm going to announce in a minute. Is this catch box on? Is it? No. Now? Yeah. All right. Let's start with the man.
Hey everyone, you'll hear me for the next hour anyway, so I'll keep it brief. Hi, I'm Juergen. Great to be here.
Hi everyone, I'm Joe Granger. I'm on the Spring Security team, and going to do an architecture deep dive at 140. So come and check it out.
Hello, my name is Dave Sayer. I'm here from London. I'm also on the Spring team, and I'm giving a talk this afternoon about Spring Security and AngularJS. Ask me anything about Spring Boot, Spring Cloud, anything like that if you see me in the hallway.
Hi, I'm Chris de Volder, and I'm on the STS team, so Spring Tool Suite. And at lunch, I'm going to give you a demo of Spring Tool Suite and all the cool stuff we do for Spring Boot.
Hi, I'm Zach Conter. I'm a consultant with Source Group. We're going to be doing a talk at 10:35 on AWS fundamentals and the benefits of highly opinionated systems.
So we'll just pause there for a second. Source is actually one of our sponsors. If you could just say a little bit about, they bought our breakfast, so thank you for that. Yeah, you could just say a little bit about what you guys do.
Yeah, so Source Group is a AWS partner, a partner of Pivotal now. We're a technology consulting company that's helping larger financial services companies on their cloud journey.
And Jonathan is their leader right over
there. That's the guy.
He's the guy who actually signed the check for the breakfast. There you go.
Hey there, so I'm Mike Villager. I'll be giving a talk this afternoon about adding performance metrics in your continuous integration and continuous delivery pipeline. I'm from Dynatrace. We're also one of the sponsors. Kind of came in at the last minute there, but yeah. So we actually make a application performance management solution that we're pivotal partners from the Cloud Foundry perspective. So we have multiple product suites that are available for ensuring the performance and availability of your system is working the right way. So
you all got a raffle ticket? Everyone got one? So Dynatrace provided the giveaway. So at the end of the day, we're going to draw, and there'll be a prize. So, and it's a good one because Donna Trace was very generous. So.
Hi guys, I'm Adib. I'm part of the platform architecture team here with Luke. I'll be doing a presentation about microservices security. So if you want to learn about all the protocols like OAuth, JOT, various other things, come to my presentation.
Hello, Spencer Gibb. I work on Spring Cloud. I'll be talking about different discovery and configuration systems later today.
And that is a cool shirt. Can we see that?
I know.
Big jar no more. Awesome.
Hello everyone, my name is Juergen. So I'm from Ontario's Teachers Pension Plan. So and one of my colleagues will talk about the migration from legacy to microservices. So if you have headaches with your legacy systems, join our presentation. We'll talk about the lessons learned as well as the solutions. Thank you.
They're the most advanced DevOps shop I've seen in Toronto.
Yes, and one of our DevOps guys actually is here, so feel free to ask questions over there. It's awesome.
I'm Bruno Schmidt with IntelliWare. I'm not giving a talk today. We are providing lunch. It's going to be hard to beat breakfast. We'll see what we can do. IntelliWare is about 100 people strong custom development shop just on Adelaide and University. We have a bunch of our clients here as well, so welcome. One of the things in one of our COEs, we kind of did a bit of an inventory of the technologies that we use for various clients, and Spring came up regularly. So we had a bunch of our folks here. Yeah, I guess that's it. So.
Thanks for providing lunch.
Yeah.
All right. What? Oh!
Shut up at the end.
The closing speaker.
Yeah, my name is Marius Bogovic. I'm on the Spring team as well. I'm going to talk about how to build data processing pipelines for streaming and batch using microservices and how to run them on cloud platforms. So, as Luke said, this is my last session. My session was last, so be there.
Hi, my name is Rossen Stoyanchev, and I am a developer on the Spring Framework team. I'll be taking the stage after Juergen, talking about more about Spring 5 and the reactive themes in Spring MVC, which is mainly what I work on.
Okay, do we get everyone? Pivotal Labs is going to do a talk on some project work that they do. Is there anyone from that group here who wants to key your session? Are you coming to do this? All right. Catch.
Hi, my name is Nader. I'm here in Pivotal Labs. We're going to be giving a talk, I think, at 10:35 about how we use Spring Cloud and our tool called Convoy that helps us with tracking all of our projects from GitHub to Pivotal Tracker, and how our process here in Pivotal Lab works with a bunch of people from our project.
Awesome. And of course, our biggest sponsor is Pivotal. They paid to fly all our speakers in and all the snacks you can eat all day. So by the way, in the kitchen, help yourself. There's snacks, there's drinks, there's coffee. Bathrooms are directly behind, and if you go downstairs, there's all bathrooms right by the kitchen. Snacks and drinks down there, so help yourself there as well. So you all have this site. Keep an eye on that. Now, I know a lot of you are looking and saying, there's 2 sessions I want to see, but they're at the same time. Don't worry, we have professional recording equipment. We're going to record all sessions and make them available on a YouTube channel after. So you're going to have to make some choices from all these awesome speakers, but at the end of the day, you can see it all. So, all right, let's go. So have fun. Let us know if you have questions. Just come to the front desk if you need anything, and we will let the champion begin.
That's better. All right. Yeah. I see something. I'm sending it. Something's happening, something's happening. And we're here, right? Okay, and it's not frozen. Wonderful. All right, welcome from my side. I'll just introduce myself quickly again. My name is Juergen Hoeller. I'm serving as the Spring Framework project lead, as in the Spring Framework open source project. Everything you can find on GitHub under Spring-Framework. It's basically underneath my little umbrella here. And I've been doing this for a long, long time. I co-founded the project, the Spring Framework project on SourceForge back in the day, 2003, long time ago. Spring has made a long way from there. Right? It's one of the longest living open source projects that's actually still actively developed and therefore alive in 2016. Hibernates, of course, has been around for a long time. This is an ecosystem. We know quite a few of the other open source projects and the people behind those projects rather well. But these have been interesting times, and we've seen a lot of progress in the Java ecosystem over those like 13 years. And Spring certainly followed along and was actually arguably a driver for quite a few of those trends. So from the very origins in Spring Framework 0.9, we're now moving on to Spring Framework 5. In Springland, we are somewhat conservative with our major version numbers. We don't just bump them every year. Like where's Chrome right now, 53, or Firefox 49? No, we're not like that, right? We use version numbers more in the traditional semantic versioning sense. We actually use the second digit. Spring Framework 4.0, 4.1, 4.2, 4.3. Those second digit releases, 4.1, 4.2, and so forth, are actually very significant feature releases on our end. We bump the major version number there in the beginning if we do something really major to the framework code base, like raising its baseline. We're going to get to that in just a bit. But there's something else to mention. The ideas behind the evolution of Spring don't just evolve on their own. This is an ecosystem once again, and there's a lot of cross-pollination happening. So it's very much about industry trends, about trends within the Java ecosystem, trends in the Java language, and Spring just naturally interacts with those general trends. I'll get back to that a few times. So we actually connect to many things happening around us. And Spring 5 is a great opportunity there. Right, so why the subtitle? I don't usually use subtitles, but this is just too easy a win here. Well, we have several themes like JDK 9, like reactive programming, and you'll hear quite a bit about reactive programming afterwards in Rossen's double pack session. I'll give you a bit of a teaser in this one. And we generally spend a lot of time focusing on microservices architecture. We are not a particularly strong fan of overselling microservices or the term itself. You won't hear it that often from us. But we provide a lot of enabling technologies for what's commonly known as microservices architectures. So if you want to put it into a sweet tagline, we enable reactive microservices on JDK 9. In practice, we enable lots of variants thereof. But if you wanted to bring it basically onto the very latest and use every single bit that we're doing in Spring 5, that's the sort of architecture you would need for it. All right, so much for a quick intro. Let's start with the state of the art. And the state of the art, just a brief summary, is Spring Framework 4.3. It's actually a very recent release. We released it in June, just a couple of months ago. It's the last 4.x feature release. There won't be a 4.4. The 4.3 line is up for an extended support life. So again, this is a kind of a policy that we developed over the years. We have parallel maintenance of some branches of the framework, but usually just the latest within each major branch. So currently, Spring Framework 3.2 enjoys a similar extended support life, but it's actually being end-of-life end of this year. So there's no more Spring Framework 3.x, 3.2 support beyond the end of 2016. The next one up for such an extended support life is Spring Framework 4.3. 4.0, 4.1, 4.2 all just had a short, like a 1 year and a bit support life. They've always been superseded by the next feature release. So currently we are still supporting 4.2 just for a further few months, but we really want you to upgrade to 4.3 because it's got the same system requirements, because it's generally a very smooth, straightforward upgrade from our perspective. 4.3 with its extended support life in parallel to Spring 5 will be supported at least until 2019. Basically as long as there is demand and as long as the system requirements are relevant. Now, system requirements. This is no different from Spring Framework 4.0. It's basically, or not radically different. This is JDK 6 Plus and Servlet 2.5 Plus for the most important ones. So you can run it back on WebSphere 7 or Tomcat 6, but in particular, you may also run it on the very latest. In Spring, we have a tradition of embracing the latest generations of our target deployment environments and third-party libraries, while at the same time retaining compatibility with earlier generations. We're pretty good at doing this, using some reflection at runtime, clever checking of what we're running against. You won't have to set it up. If you're an active Spring user, you probably just expect this to work. Wherever you deploy it, it just works. You don't have to configure the JDK 6, 7, 8 level. We auto-detect it and auto-adapt to it. So from a modern day Spring perspective, I suppose most of you actually work on JDK 8, but let's do a quick check. Who's working on JDK 8 right now? Maybe worth doing an inverse check. Who's on JDK 7? Let's poll it specifically. Anyone on 6? All right. So I guess we're doing something good for you there in having extended support for 4.3. Who's actually on Spring Framework 4.3 already? This generation of Spring that's just a couple of months old. 4.2? Active 4.2 users? 4.1, 4.0? Older 4.x releases? 3.2? Quite a few. Who hasn't actually worked with Spring at all? Just anyone? Right. All right. There's something good for you this day, in the course of this day, for sure, for each and every one of you. But yeah, the system requirements won't change. 4.3 keeps it up, so we are going to keep supporting JDK 6 Plus until 2019, basically, or until the underlying technologies get the end of life, right? You won't get support from the framework side for technologies that have been end of life by their respective vendor, of course. All right, the other noteworthy part about 4.3, I'll spend just a quick few minutes on a later slide, is refinements in the programming model. 4.3 is actually a really significant feature release. The amount and extent of those refinements in the dependency injection model and also in Spring MVC that we brought into 4.3 would actually typically rather appear in a 5.0 release. So in that sense, 4.3 is a sort of 5.0 backport. Features that we could easily bring into the 4.3 line because of 4.3's architecture, because they are easily portable to JDK 6 Plus, those features we did actually bring back to 4.3. So in that sense, some very significant, maybe not radical, but significant refinements to the programming model are actually already there in 4.3 for immediate consumption on all of those target environments. So I'll just get back to this in a bit, but let's contrast the setup with Spring Framework 5.0. This is, from our perspective, a brand new framework generation. It's a major generation. We raised the baseline. We set it up for its own, extended life. It's a 2017 plus generation. We intend to go generally available in March next year. And this is basically the Spring Framework generation for the years to come, right? So we'll have system requirements that are hopefully appropriate for that time frame. We raised to JDK 8+. We enforce Servlet 3.0. We actually strongly recommend Servlet 3.1, and for quite a few pieces in the framework, it's Servlet 3.1+ effectively. This is, in summary, a Java E7 baseline. It's the latest baseline, right? We enforce the latest JDK generation and the latest specification generation for the Java EE-related efforts. This is just the baseline upgrade, important for us. For you, well, if you're on that baseline already, it doesn't make that much difference, does it? But for the actual feature themes, we strongly focus on infrastructure. There's many other refinements in many specific places in the framework, but from a higher level picture, we have 3 key infrastructure themes. And that's JDK 9, HTTP 2, kind of connected to Servlet 4. In the meantime, I would reverse that because Servlet 4 is not here yet, but HTTP 2 is. So that's kind of an important general industry theme that we're connecting to. And it's reactive architectures. Reactive programming at all levels, but in particular reactive programming for web endpoints, for HTTP endpoints, a kind of reactive variant of the Spring Web Stack. Most of those themes, all of those themes kind of interconnect, and we'll see why we chose those 3 specifically. But first, just a quick comment on a quick detour towards the core container. How do we actually choose what makes it into 4.3, what makes it into 5.0, into the next generation? We are largely driven by the ability to actually implement it in that framework architecture. So it's not so much based on the impact of the feature. From that perspective, many things in 4.3 should have gone into 5.0. But we actually brought them into 4.3 because we wanted to complete the story. The annotation-based component model, as you know it, the annotation-based component model, both at the core container level and in particular also in Spring MVC, has reached a certain point of completion in the 4.x line. We wanted to reach that point of completion in 4.3. So we've brought many final kind of refinements. I mean, one is never done here, right? But many refinements that we still had in the plan and just never got around to, we carefully selected and brought into 4.3. 4.3 also has seen many runtime enhancements. So if you're wondering about the need to upgrade, just please do it. Upgrade to 4.3 for the latest runtime refinements. There's many efficiency refinements across the framework, in the internal data structures, in the hotspot code paths, where we're carefully trying to avoid unnecessary waste of CPU cycles, down to the level of avoiding even the most minimal string concatenation and aggressively using caches wherever we can. So we spent considerable effort, and some of our community contributors spent considerable effort helping us to optimize the internals of the framework at runtime. A lot of this has made it into 4.3. This is really a very worthwhile upgrade. Now, what's exclusively in 5? Well, there are quite a few things that we can only really do now, as we have raised the baseline to Java 8+. Just to give you an indication of the pain of being a framework developer. As in Spring 4.3, we allow your code to use Java 8. You may declare Java util optionals or streams, use repeatable annotations. In your interfaces, in your classes, you can do everything the Java 8 language allows for. Using lambdas, using method references. Spring enables all of this perfectly seamlessly in your code. But the framework itself is JDK 6 baseline. So within the core framework code base, we can only use JDK 6 and optionally, conditionally support JDK 8 when we detect it in your code, right? As we detect it in your code. We reflectively look at your classes, at your endpoints, at your method signatures, and adapt to them. We can do this in a smart way based on whether we run on JDK 8. So from a usage perspective, hopefully the framework feels like a Java 8-based or Java 8-oriented framework to you already in 4.3. that doesn't change the fact that internally we are JDK6 baseline, and that can be a bit of a pain, and there are some things we just cannot do. We cannot expose hard Java 8 type references in our core interfaces or core classes, core constructors. So there's no Java util optional or stream or completable future kind of hard declaration in the Spring code base. We can only reflectively support it in your code, but not declare it in our own, not internally, and not in the interfaces and the public signatures either, which is somewhat constraining. So that's something we did in 5.0 M1 already. We went through the entire code base, updated it to declare default methods, Java 8 default methods in the interfaces to make the implementation of those interfaces easier. We consistently declare functional interfaces now for the readability and the toolability of just the use of lambdas and method references against those. The Java 8, the use of Java 8 types is not as, it doesn't have as much impact, but if you carefully look at some of the classes and interfaces in the 5.0 milestones now, you'll find a couple of new overloaded variants that make good use of Java 8 types. Right, in 5.0 M2, just released last week, we had a bit of a different focus. It's about efficiency on startup. There is a kind of a trend having an impact on our startup requirements, because if you take a traditional enterprise architecture, startup doesn't really matter that much because it's not bootstrapped and shut down too often. We traditionally optimize for hotspot invocation code paths, incoming web requests being processed as efficiently as possible, sometimes even at the extent of slightly extended startup times. Coming basically at a price, it's a trade-off in quite a few cases. However, now in a more elastic cloud environment, some of the deployment units, some of the nodes, some of the service instances may be bootstrapped just for a brief period of time under high load and just taken down afterwards. If those are implemented with a Spring application context arrangement, there can be costly startup steps in that application context scenario. For example, a component scan, very commonly used, instructing Spring to find components in the class path. This can be costly depending on the environment that you're running on and depending on how extensive the search needs to be. There are ways of getting around it. I mean, you can just enumerate the components yourself or minimize the base package part of the class path that needs to be searched. But in some scenarios, that's not good enough. If we repeatedly start the same deployment unit with the very same arrangement, the very same class path, we kind of repeatedly look for the same components. We reconsidered how we can optimize this while preserving the user experience. So for you just to declare a component scan instruction, the same component scan instruction as before, but more efficient repeated startup. And our current solution, it's a bit of experimental still, is a component index, an index file that can be included in the jar that you're deploying, and the framework will detect and prefer the use of that index file over a class path scan. So as long as this index file provides the information necessary to satisfy the scan requirements, the scan conditions, we make use of that index instead of actually going into the class path and traversing it. For certain scenarios, this can be a very important optimization on startup. And of course, depending on your build arrangement, depending on your tooling, you may automatically generate that index at build time. It's of course an optional feature, but it's one of our core container themes, startup times, efficient startup. And another theme that is high up on the list for 5.0 M3 is programmatic bean registration. You may be aware that the core container has a lot of programmatic facilities already, bean definition registration, many ways of providing the container with metadata about your components. And all of our XML configuration formats or the annotation-based configuration formats, they all translate to that underlying bean definition model. However, if you wanted to completely programmatically set up a typical minimal Spring application context arrangement on startup, there's some noise involved there that is non-ideal. We want you to have a better experience when handcrafting a minimal Spring deployment unit, for example, for a microservices scenario, where you might not want a class path scan, where you might just have a few components with specific creation requirements, but you do not want to use the annotation-based model, you do not want to use factory methods. You'd rather provide a supplier callback for creating the instances, doing it a little bit more in a Java 8-oriented style as well. This is a theme we have yet to explore. We're in the middle of the milestone phase, not done yet, but this is something I'm personally looking forward to. All right, so that's quite a bit of core container stuff. Every Spring Framework generation does quite a bit of core container overhaul, and 5.0 is no different. Now, so much for a little bit of a core container selected deep dive. Let's go through the main infrastructure themes, the major infrastructure themes. Now in JDK 9 is an interesting one. We've been tracking it for 1.5 years already. JDK 9 has been in the works for quite a long time, and it's still not there yet. It was originally supposed to go generally available in September 2016, like now. It already got delayed to March 2017 a while ago. And just like 2 or 3 weeks ago, they announced that it's going to be delayed until July 2017 now. So it's kind of, whenever you're trying to chase it, it just moves away, right? This is a bit painful for us, since we generally embrace new JDK generations. We did so with Spring Framework 4 and JDK 8. We were ahead of our time, really, ahead of the industry there. We delivered comprehensive JDK 8 support back in Spring Framework 4.0, 3 months ahead of the JDK 8 GA release. So we were 3 months ahead of the JDK. Don't tell anyone we were building against pre-release JDKs and published those. But so literally the Spring Framework 4.0 jars were built on a pre-release JDK. Because JDK 8 was delayed as well. It's a little bit painful to track JDK releases, but it is important for us, and I would argue it's important for you. Even if you may not upgrade to JDK 9 immediately, it is a very important step for a framework to take, to just embrace a new JDK generation where once you choose to do the upgrade, it is as seamless as it can possibly be. Now, the reasons to upgrade to JDK 9, there are plenty. And it's not just Jigsaw, actually, not just the module system. JDK 9 delivers a lot of runtime refinements, virtual machine refinements, garbage collector refinements, the compact strings arrangement at runtime, which can significantly cut down memory usage of your JVM, in particular in a typical web application, in a typical Spring application. There are many runtime refinements that make it worthwhile. So even if you just have a JDK 8-based application, JDK 8-based deployment unit, just dropping it onto a JDK 9 virtual machine may already deliver significant benefits. So the upgrade will be worthwhile once it's there. But there is also some very specific features coming your way. There's of course the omnipresent module system, Jigsaw. This is the reason why JDK 9 keeps being delayed. Everything else is basically ready. But Jigsaw is just heavily debated, as module systems tend to be. And yeah, I'll just show you a brief example on the next slide and what the issues really are. But it's not just Jigsaw as a major feature either. There's in particular a new HTTP client and a general HTTP 2 theme. JDK 9 is the first JDK generation delivering a proper HTTP 2 enabled stack for the ALPN protocol, for a seamless translation of an HTTP 2 setup onto the JVM. This comes somewhat late. I mean, HTTP 2 is already out there in the industry. And it's a little bit of a shame that everybody seems to wait on JDK 9 there. HTTP 2 is our next infrastructure theme, but you see an immediate connection here. It's also one of the JDK 9 themes. So before we just discuss HTTP 2 a bit, a quick note on Jigsaw. We could go on and on about this really, but I'll just give you the status of September 2016. Jigsaw is basically an arrangement where a jar file, an application jar file or a framework jar file, library jar file, can be enriched with a so-called module descriptor. This is a module info file, like module-info, basically the syntax shown below, a little bit like a package-info Java file, right? That you put into the root of your packages, mostly for the Java doc. The module-info is the same kind of idea at the root of the jar file. A formal description of your module with a module namespace, so a module can have a symbolic name, and it can express requirements on other modules. It can also choose to export certain parts of its own code base, certain packages, to other modules, or inversely, of course, choose to hide them from other modules. Now, this is the basic idea. In practice, it's actually a reasonably sane effort. I mean, it's still a jar file. It's just an extra descriptor. The naming policy for modules is pragmatically aligned with the common naming policy on Maven Central. So at the moment, the suggestion is that it's basically the Maven Central artifact name, just with dots instead of dashes. And there's even a so-called automatic module feature where you take existing jar files, like the Spring Framework jars or other library jars, put them onto the so-called module path in JDK9, and the JVM then turns each of those jar files into a runtime module representation. Because that's exactly what the JVM is building. It has a runtime concept, a runtime representation of the module structure, instead of just a flat class path where basically jar files are just containers for class files and everything is dumped onto a single flat class path. You have now isolated units. Each jar file is represented as a module. You can even reflect on those modules and their structure at runtime. There's reflection support for it. And the JVM can kind of optimize and manage those modules since it formally knows about them. That's generally a good idea. The devil is now in the details. What's exported by default, for example, right? Is everything exported by default, or do you have to have export clauses for all the packages? Many of those things are heavily debated still. The current arrangement is reasonably straightforward, but there are many stakeholders not too happy with it. The general idea is that for an application unit, like for your, maybe for your repository module, you would specify something like this simple module descriptor with, if it's using Spring JDBC, just a corresponding requires clause. That's the model from a Spring perspective that we want to enable. Right? So we take a very pragmatic stance. We are not going to focus on Jigsaw too much. We intend to allow the use of Jigsaw in your application deployment units. If you choose to use Jigsaw and choose to use module descriptors, this should naturally work with the Spring-provided framework jars. And, well, as of September 2016, as of mid-September, it actually works. If you're using the latest Jigsaw build, the latest JDK9 with Jigsaw build, even the defaults work very nicely with the latest Spring Framework jars. If you use a Spring Framework 5.0 M2 on JDK9, on a recent JDK9 build, the experience is reasonably straightforward. We don't ship module descriptors ourselves yet. We actually rely on this automatic module feature. If you put the Spring Framework jars, our provided jars, onto your JDK9 module path, the code internally is aware of this. We had to do some refinements, but the automatic module defaults work for us. Automatic modules see all other modules, so the framework is able to see your code and see the class path resources in your jars. You can even do class path scans, and you can do extensions in meta-inf. So all of the features that we've been testing actually work. I hope it stays that way. JDK9 is not at the end of its road yet. Some defaults are subject to change. So fingers crossed, but there are no guarantees that there couldn't be further hurdles along the way, as long as JDK9 is not quite done. Rest assured, though, we are tracking the progress in JDK9. We keep making sure that the latest Spring Framework 5.0 milestones work with Jigsaw if you choose to use it. Keep in mind, nobody forces you to use it. You can upgrade to JDK9 and keep using the class path. No problem with that. No issues either, because it's the same class path arrangement as on JDK 8, except that the JDK doesn't export some of its internals anymore, which is hopefully not a problem to you, just a problem to certain frameworks. And we know how, for the moment, we know how to deal with it. So the upgrade to a JDK 9 class path arrangement is very straightforward. You get a lot of the runtime JVM benefits that way. You choose to use modules if you feel that it adds value to your application structure. All right, so much for a little bit our take basically on JDK 9. Now, I've already referred to HTTP 2. This is from my perspective, a very key theme. We can't actually properly honor the effort, but just quickly summarizing, HTTP 2 is the first proper revision of the HTTP protocol since 1.1, which dates back to 96. It's a 20-year-old protocol. So for the most modern applications and systems that we are building, we rely on a communication protocol that's 20 years old. We got HTML revisions, right? But HTTP? So HTTP 2 is really overdue, and it actually delivers. It delivers a lot of very worthwhile runtime optimizations. A binary representation of the payload, headers compression, right? Symbolic references to a certain headers declaration, follow-up requests just include a link. Like I have the same headers, I don't repeat the text for all those headers and their values. Just a symbolic link to a previously sent headers arrangement. There are so many things. The multiplexing of connections, avoiding those good old traps of like how many concurrent requests am I allowed to send to the same server. Some of those problems just almost naturally disappear with a proper HTTP 2 arrangement. Now, a lot of players in the industry did their job. The browsers, both on the desktop and the mobile browsers, Chrome, Firefox, Edge, Safari, they all did their job. The HTTP 2 support is actually pretty far along. Most of the infrastructure out there is ready for it, but then along come the servers. And many of the server systems are just traditional HTTP 1.1 servers that do not speak HTTP 2, even if the client indicates a desire for it. And that's where we need to be up for it. Let's make sure that the next revisions of our systems are HTTP 2 enabled as far as possible. This is unfortunately not quite trivial because the JVM doesn't include the TLS stack, which is necessary for HTTPS in HTTP 2. We don't have Servlet 4 yet. I mean, God damn it, we don't have Servlet 4. It's actually so overdue that it's worth just pointing out that finally we got a target date, September 2017. Now, if it's actually happening, but this is 4 years, more than 4 years after Servlet 3.1. This is almost so far overdue that I'm not sure that the industry at large will care once it's actually released next year. For the time being, please focus on the actual containers, the server containers themselves, Tomcat, Jetty, Undertow, Wildfly, which embeds Undertow, and as far as I'm aware, the latest WebSphere Liberty, for example, as well, they all have an HTTP 2 story. They can all be set up with certain effort in a way where on a recent JDK 8 installation with an overriding ALPN stack, they can serve as HTTP 2 servers. By all means, consider those options. There is no excuse. Waiting on Servlet 4 is not a good idea. Once we get a spec document, basically a PDF file next year in September 2017, it still takes a while until the servers catch up. Don't wait for it. Take the existing servers, check out their configuration options for HTTP 2. It may not be super trivial. You may need modifications to your JVM setup. Consider it and basically do it if you can. Tomcat 8.5, Jetty 9.3, that's all. That's basically the latest incarnations of those servers. They all have a story in that respect. Now, Servlet 4 is nevertheless relevant. The effort itself is more a definition of the common rules of HTTP 2 support in servlets. there's actually not that much need to leak it through the Servlet API. The most important part is that Servlet 4 will actually force Servlet containers to have an out-of-the-box HTTP2 story. Now, the JDK9 HTTP client and the JDK9 ALPN stack is actually a really good fit. I mean, there's a bit of a mismatch because Servlet 4 is JDK 8 based, but at least by late next year, we will have out-of-the-box JDK 9, and we will hopefully have like Tomcat 9, Servlet 4 based. So we will have an out-of-the-box properly defined HTTP2 stack. That's great. We will be tracking it in Spring Framework 5.1. We will do our share to make sure that once those pieces arrived, the out-of-the-box experience is as good as it can be, not only in Spring Framework, but also in Spring Boot in particular. But that's a year away. As mentioned before, we are now in September 2016. We need to get our act together, consider the options that are out there right now. Spring Framework 4.3 and the 5.0 milestones are essentially prepared as far as we can prepare them. It's primarily up to your Servlet container setup at this point. All right, so our next major theme is reactive programming. In HTTP 2, we already have a focus on efficient use of the networking infrastructure. And reactive programming is essentially kind of attacking the same problem space. Implementing, in particular, server-side processing logic in a way where we most efficiently use the I/O and CPU resources on the server. So it kind of naturally goes together to some degree. I mean, even if you can completely independently set up HTTP 2, reactive programming tries to kind of fit into the same picture. Reactive programming now is a pretty broad term, can mean many things to many people. There is the so-called Reactive Manifesto out there. That's generally a fine statement of intent, right? A fine summary of kind of the goals of the qualities that we want to achieve. The Reactive Manifesto basically just throws a couple of terms out there, of related qualities out there that we would like to achieve. And it's in particular about high load against server-side systems with predictable, stable behavior under high load. Responsive behavior, resiliency at that level, instead of just maxing out a server container thread pool and being unable to accept further requests just because some other threads are blocked by waiting on external systems. We want to be able to still serve clients, not keep threads from the thread pool blocked for user requests. The Reactive Manifesto translates very nicely onto a non-blocking programming style. There are many ways of achieving this, many patterns that allow you to get at least towards a more reactive style. What we are focusing on is a very specific arrangement. There is a specification called Reactive Streams out there. It's actually an open source project, reactivestreams.org. Just a couple of types, modeling something very essential for us. The interaction between publishers and subscribers in a reactive processing stack. So it's very I/O oriented. We're basically assuming we are building an IO-based system, like a typical web application, where we have to reach out to a target data store. The target data store has to provide data back to us, and we are sending it back to the client after some processing steps. The hardest part about it is to make sure that the underlying data stores basically react at an appropriate time, instead of just waiting on a data store, blocking until we get the complete data back, and then kind of taking that data and writing it out to a servlet response or HTTP response of some kind. We want to have a smooth streaming arrangement where data can be processed as it comes in and when it comes in, not blocking for any external call, for any external system, an on-demand arrangement. And reactive streams are a very minimal but essential arrangement for modeling the interaction at the infrastructure level. This is not something you're going to code against typically. This is something that your data store drivers, your web frameworks, your reactive libraries are going to comply with and going to naturally support. The core arrangement, which is basically just a bunch of interfaces, is also repackaged into JDK9. So we connect back to JDK9, to the JDK9 theme here, as Java util concurrent flow. The same types that we find in org reactive streams can also be found there. Now the reactive library space already has RxJava out there. And RxJava is very popular. I'm sure quite a few of you are familiar with it. RxJava 1, however, is not reactive streams based. And RxJava 2 is kind of trying to attack the reactive streams architecture as a little bit of an afterthought. RxJava nevertheless does a fine job about what it originally was set up to do. However, for our needs in a in the Spring component model and in a modern day JDK 8+ environment, we rather focus on Project Reactor 3.0, which is actually a Pivotal sponsored project. The lead implementer, the lead developer is Stefan Maldini, one of our Pivotal team members. Reactor 3 is an open source project as well, or already has a little bit of history, but Reactor 3 is almost a reinvention of a reactive composition library, which is out-of-the-box reactive streams based, very much aligned with RxJava. There's even close collaboration with the RxJava team. David Karnock, one of the RxJava lead developers, is a key contributor on Reactor as well. So there's close alignment, but with different assumptions. Reactive streams from day one on, and JDK 8+. So Reactor 3 has just two central types that you are typically interacting with, called Flux and Mono. And you're going to see more of this in Ross's double pack session that follows right afterwards, I think, here. But I'm going to just give you a few teasers and a few hints at what this means for a typical Spring web application, if you choose to code that way. So this is just a graphical illustration of the reactive streams interaction model, where basically underneath the covers of your stack, the components, the different kind of I/O drivers involved can interact with each other. In particular, a subscriber can subscribe with a publisher. The publisher will only then start to actually publish data as the subscriber requests it. So it's also a matter of, it's an arrangement for flow control. Instead of a publisher just pumping out data and hoping that somebody can swallow it, at this time, a subscriber actively requests the next kind of chunk of data to process. This allows for a streaming-like processing arrangement. Data can be transformed and written out as it actually comes in a callback model. So with a processing chain, a processing arrangement registered at runtime, the application kind of provides the rules for actually connecting and connecting the publishers and subscribers, and for declaring the transformation steps, and the runtime environment, the runtime reactive stack makes sure to invoke the pieces, the components, at the right time as data is actually available for processing. So let's maybe just move on to a Spring Web Reactive example. What does this actually look like? What can you actually do with this at the programming model level? Well, after evaluating our options, we chose to design a parallel stack in parallel to servlet containers, to a traditional server container Spring Servlet MVC stack. We have a new variant called Spring Web Reactive. I'll just show you the diagram right away. So to the left, we have a traditional Spring Servlet stack. A servlet container underneath, like Tomcat, Jetty, whatever. The Servlet API very immediately exposed to the application, and Spring Servlet MVC sitting on top with direct interaction with the Servlet API. The Servlet API actually representing itself in the SPI contracts. You may even use Spring MVC handler methods and declare HTTP servlet request, you can get direct access to the underlying servlet API. This is very much intentional. Spring MVC, traditional Spring MVC is actually called Spring Servlet MVC and is built on the servlet API, exposes all the features of the servlet API to your application. Our programming model on top, this is the Spring Add Controller model with request mapping annotations. So basically Spring MVC as you know it. Now, to the right, this is what's new in Spring 5. It's a new stack, a reactive processing stack with Reactor as our common reactive engine underneath. The Spring Web Reactive abstractions and the Web Reactive kind of APIs and SPIs that we bring into the code base here. And a Spring MVC-like programming model on top, so like an add controller, add request mapping model that you may choose to run on the Web Reactive stack. You choose to run it there. You choose to actually build controllers, reactive web controllers for that stack. So we are not trying to abstract this. You make a conscious decision of running and building your controllers for the servlet stack or for the reactive stack. Just using common stylistic elements like the controller request mapping annotations. And there's also a sweet little new model just appearing here, which is our router functions and handler function arrangement. Basically a functional web endpoint model that we introduced in 5.0 M2 last week, running on the same Web Reactive stack. So I'm just going to give you a few examples of what this actually looks like. So at first glance, this controller class may look like a regular Spring MVC controller, but look closely. We are reusing many common elements from the Spring programming models or regular this is a regular controller class, a bean, typically running in an application context, uses request mapping annotations. It's actually using the latest variants of request mapping annotations. These are 4.3 annotations, get mapping. This is basically a shortcut for request mapping method equals get, variants that we introduced in 4.3. But this is regular Spring MVC. However, the signatures, get user and get users, return, in this case, reactive types, reactor 3 types, mono and flux. So instead of just passing fully built data back to the web framework, they are rather building a reactive composition arrangement, basically instructions for how to obtain this list of users back to the framework, and the framework may then trigger the invocation of that processing chain based on incoming data. The typical arrangement can actually be found here. You're not meant to just do magic stuff or complex stuff at the controller level, really. You're rather meant to interact with other components in your architecture, like repositories that are able to provide data to you in a reactive fashion. So we delegate out to a user repository component here. Let's just apply the assumption that that user repository maybe talks to a Couchbase or some data store with reactive data store drivers. Because in order to get all the benefits of a reactive model, you are really meant to apply the reactive paradigm all the way through, down to the data store level and back up. It doesn't make much sense to code web controllers reactively when you then block waiting for the data store one level below. You really need to apply it through the stack. Reactive programming, a reactive architecture is a non-trivial affair. What we are providing in Spring 5 are basically enablers and a just comprehensive model for it, for setting it up at the web level. So that basically the Spring Web Stack, it does its job of enabling a reactive processing chain, but an important piece to bring in here is actually the target data stores. And the target data stores is, well, you may code those repositories, of course, yourself. I mean, we don't really apply any special rules there, other than those repositories following the same conventions. In this case, they are meant to provide a flux or mono to us directly. There's an ongoing effort in our Spring Data project to provide out-of-the-box support for such repositories in the Spring Data project. So there's ongoing work in other Spring team related project teams delivering the repository side or delivering a variant of the repository story that's needed here. So this is just technically a teaser for what this may look like. Rosson's going to follow up with a much deeper coverage of the implications. But this is not the only thing you can do. This is just a familiar Spring MVC-like programming model which may interact with a reactive processing stack. We have another variant, just released last week, which works with a very different design assumption. This is a functional web endpoint model. It's essentially doing the same thing, but you're not declaring controller classes with annotation-based handler methods and reflective invocations of those handler methods. Instead, you provide the same rules using a programmatic composition API. The outcome is what we call a router function. A router function is essentially a functional callback containing instructions for incoming requests, for binding incoming requests onto certain target handler functions. This may look like a domain-specific language almost, but it is actually Java 8 code. It's making use of Java 8 language features in a reasonably natural Java 8 style. It is somewhat similar to the use of Java util stream in Java 8, collection streams. If you've ever looked at collection stream examples and the way you can arrange collection stream processing code, this is very similar in style. There are a couple of static inputs involved, so just if you're wondering where the root function, root method comes from, the route method comes from, this is basically two missing static inputs that you're not seeing here. But the outcome is hopefully reasonably straightforward to read. These are two request bindings. For the /users path, we bind to the repository find all call below, and for the user's ID with a path variable, we bind to the repository find by ID method. Very similar to the code provided here. The difference is that here you're actually declaring specific handler method signatures. The framework looks at your signatures and kind of naturally understands what you intend to do. We know that this is a path variable. We automatically convert it to a long. You can have a flexible return type, and the framework naturally understands it through reflection. We just look at your code and make assumptions based on your signatures. Whereas in a programmatic world, the signatures are basically fixed. You're not seeing the actual signature for the handler function here, but handler function basically takes a request and has to return a response. It always has a request object coming in and a response object to go back. And this code here is basically a functional variant of taking the request, obtaining a path variable, basically resolving the path variable ID, converting it to a long, and passing it on to the repository find by ID method. This is somewhat simplified code, so take it with a grain of salt. There's no error handling here. But it's basically what stylistically you'll typically be doing in a handler function. Then you're building a response with a builder API. The response actually has an OK status, and it takes this mono of user and just kind of converts it into a body. This from publisher method is also a static import. It's called publisher because Reactive Streams publishes. Both mono and flux are Reactive Streams publishers. Any Reactive Streams publisher can be passed in here, for example, if provided from a third-party reactive driver to a data store. Now, from publisher has then conversion applied. There is a message reader, message writer model underneath the covers. There's out-of-the-box support for XML conversion and JSON conversion. We're using the Alto XML parser. With JSON, we're trying to work with the Jackson development team to have a more reactively oriented API for partial rendering in Jackson, because ideally, of course, you do not insist to render out an entire document at one point. You rather partially render parts of the document as you get the data from the repository. You partially render it out to the web response as it comes in in particular for longer responses. So this code here is non-blocking. It doesn't block at any point as long as the repository complies. You know, if the repository doesn't block either, the web processing arrangement here does not block. So you never block a user thread. It's not like in the servlet model where the incoming request just owns the thread until you're done producing a response. You don't own any thread here. You're being called back. Parts of your code, parts of your processing chain are being called back as data comes in, is ready for processing, is available for processing. Of course, that comes at a certain price, right? At no point you should assume that there's a certain thread local state here. Don't use thread local bound transactions. Don't use any kind of open session model here. You're basically decomposing your logic into small callback steps, independently called, without making any assumptions of which thread they are called within. So it is quite different semantically at runtime. It is quite different from a servlet processing arrangement, even when doing the same job. But we're actually not done with the stylistic example yet. This is using Java 8 lambdas. So just to get a little bit more into the syntax, this is using a Java 8 lambda here. So basically just a lambda that is being bound to the handler function interface by the JDK compiler. So just using a code block lambda here with an incoming request building the response. Now there's another Java 8 language feature that is actually a pretty good fit for this kind of code. And this is method references. What if you kind of restructured that code, the same code here, same processing logic, onto a router function, where the router function is still composed using these little statically imported methods here. You kind of compose a router function based on those two endpoints. But then, for the actual processing, for the actual handler function that takes the request and produces the response, you bind to a target method through a Java 8 method reference with the : syntax. The JDK compiler, the Java 8 compiler, naturally supports this as long as the target methods comply to the interface that you're binding to. Of course, this callback takes a handler function. Handler function has a request coming in and a response to go back. Both of those are part of the WebUtil function package, Web Reactive function package. So as long as you comply to those signatures, you can use this syntax here, the Java 8 method reference, to such a target method. Just instantiate basically your handler delegate somewhere or get it from a Spring application context, bind it to a bean in a Spring application context, and refer to your methods that way. There is no reflection involved. This is not a reflective dispatch based on the method name or anything. This is actually a compiler-supported adaptation to this functional interface through the use of the Java 8 method reference feature. So not only are we not blocking, we are not using any reflection and no annotations. So it's very different from a traditional Spring MVC arrangement where you're used to many controller beans that are reflectively detected, arranged with the methods introspected, the paths bound, and the methods are then dispatched to based on Java reflection. This is quite different at runtime, but it uses the same reactive engine underneath. It's the very same abstractions underneath, the same reactive web stack options underneath. So in Spring 5, you can translate the annotation-based model using reactive elements in your annotation-based controllers, or this functional model onto the same underlying web stack. Of course, this is all very fresh. This is just a code that's literally a week old. So please take it with a big grain of salt. It's subject to change. Some of the code may still see some refinements, some overloaded methods. We're basically waiting for feedback here. Keep in mind that those are just variants of providing the processing logic to the framework, right? This is probably the most common style you would be using, in particular for large surfaces, many controllers with many request mapping paths, many routes in that terminology. You would probably go with this naturally decomposed controller model. So for a large web surface, like in a typical enterprise application. But if you're building a specific microservice with a very specific purpose and just a few web endpoints that you need to model, then this becomes actually pretty attractive. And even, I mean, here maybe once you have 3 routes, you're basically beyond one screen, right? It might not be as readable, but consider method references. Even if you have 10 routes or 15 routes to define, you actually have a nice little arrangement with one-liners that bind to your target methods. So a very easy overview over your HTTP routes and target methods to bind to. So these are choices we provide to you. Just like back in the day, we had our programmatic abstract controller hierarchy next to our annotation-based controller model. Now we have the annotation-based controller model and a functional endpoint model as options for you. All right, so much for this little tour through some of the core Spring 5 themes and related industry trends and things happening around us. Quickly summarizing, we expect GA in March 2017. This is the original JDK 9 target. JDK 9 is not happening at that point. Our intention is to nevertheless release ahead of JDK 9 with early JDK 9 support. So the JDK 8 baseline, of course, very central for our code base. Early JDK 9 support coming, even ahead of JDK 9 GA. And focus on HTTP 2 to the best degree possible on our end. We're also collaborating with the people in the over there in Tomcat land and the Jetty team to just make the story as smooth as it possibly can be. And the reactive story and everything that's connected to it. We have a reactive web controller model in the annotation-based controller style. We have a functional web endpoint model now, and we have a general focus on embedded bootstrapping. So you'll hear more about this, but you've seen it in the little diagram. The reactive web stack can, for example, run on Netty. It can run directly on Undertow Core, or it can be bound to Tomcat and Jetty or to any other Server 3.1 container. The reactive web stack has a wealth of options underneath, and it's in particular well suited for a microservices arrangement where you have an embedded HTTP kernel that you're bootstrapping inside of your deployment unit. So if you are for a follow-up on the reactive story, make sure you see some of Rosin's sessions today. And for any other questions, of course, on JDK 9 or HTTP 2, I'm happy to answer them for you. I'm around all day. If you'd like to hear something about the state-of-the-art Spring Framework 4.3, I have a dedicated session this afternoon. I never remember the time, but early afternoon, called Modern Java Component Design on 4.3.
Awesome, Juergen.
Thank you.
Awesome. And by the way, this is